Hi kids! Today we are going to work on lesson 24 in your math book. We are going to start with the application problem on page 143. So what I want you to do right now is to go get your Learn book and open to page 143. And you can pause the video if you need to. And we want to start by just reading that problem together. So it says, the zipper on Robert's jacket is a foot long. It breaks on the first day of winter. He can only zip it 8/12 of the way before it gets stuck. Draw and label a number line to show how far Robert can zip his jacket. So you need to build a number line, and I want you to pause this now and draw your number line with the unit fraction of twelfths. Okay, so yours should look something like this. You have your whole divided into 12 parts, and that represents the length of his zipper. And it said that he broke it at the 8/12. He can only zip it up to the 8/12 mark. So I'm just going to do this first. This shows how far he could zip it. Then for letter A, it says divide and label the number line into thirds. What fraction of the way can he zip his jacket in thirds? Well, we don't have thirds shown here, but I want to show you how you can think of it. When your number line is divided into another unit, like twelfths, you have to think of the relationship between twelfths and thirds. Another way of thinking of it would be to say, well, I have 12 jumps here, but I wish it was divided into thirds. So if I have 12 and I want it to be broken into 3 parts, that's starting to sound like a division sentence to me. So I have 12 whole jumps, and I want it in 3 groups instead of 12. So it's like this, kids. 12 total jumps divided by 3 groups, that's 4. And 4 will tell us the number of jumps in each group. So I started to do this before. So 1 jump, 2 jumps, 3 jumps, 4 jumps. So here's going to be one of my thirds. One jump, 2 jumps, 3 jumps, 4 jumps. Here's my second third. And 1 jump, 2 jump, 3 jump, 4 jump. Here's my third out of 3 jumps. So I know this one's hard to see. Let me try with a different marker. So here we have done this hard thing. Even though we started with twelfths, we found the equivalent fractions by dividing our total by the amount we wished we had. We wished we had 3 groups. And when we wished we had 3 groups and did the division, we found that there need to be 4 of these little twelfths between 0 and a third. 4 jumps. So I hope that helps you with that part of the application problem. When I read that one, I knew that was going to be maybe a little bit different for you, and I wasn't sure if you'd see this connection right away. Part B says, what fraction of Robert's jacket is not zipped? Write your answer in twelfths and thirds. So if he zipped it this far, before it got stuck, that means that 1/3 is not zipped, or 4/12 is not zipped. And you can count them and see. 1/12, 2/12, 3/12, 4/12. 4/12ths, not zipped. Or we could also call it thirds. 1/3 is not zipped. And these are equivalent fractions. 4/12ths is the same as 1/3, and your number line shows that to you. Okay, so that was the application problem. For your new work that you're going to do today, you are going to be seeing that whole numbers can be written as fractions. Whole numbers can be written as a fraction. So I have a couple of diagrams started here for you. The first one shows that we have a number bond, and that's what we're going to be using today is number bonds and number lines. So we have one whole shown, and we can see it's split into two parts. And I think this should not be too hard to understand. If we have one whole thing and we split it in half, we have two halves, 1/2, 2/2. And we could see that one whole, instead of calling it one whole, we could write it as 2 halves. So this is our objective, to see that a whole number can be written as a fraction. I hope that makes sense to you. What do you think is going on here? We have one whole split into 3 parts on a number line. We have one whole split into 3 parts. So what do we have? Well, we have thirds. I can even write 0/3 down here if you want to see it that way. Here's our whole split into 3 parts. So 1/3, another third, and another third. And on the number line, these just look like jumps. Here's a jump, there's a jump, and there's a jump. So 3 jumps in the whole. But instead of writing 1, we could see, oh, there's 1/3, 2/3, and there are 3/3. So this is the big idea today, that instead of writing the number 1, we could say, oh, it's the same as 3/3. Or in this model, the 1 is the same as 2 halves. Okay, that's pretty straightforward, I think. What about this? Is this true? Here our whole looks a little bit different. I've shown it as 2 halves. 2 halves. Is this true? Maybe pause the video and make your decision. This might not look like it's a true number bond, but if we think about the whole, do 2 halves make a whole? Yes, they do. And we could even write that like this, 2 halves. And now we're thinking about these littler parts down here. We have a fourth, a fourth, a fourth, and a fourth. Okay, well, let's break it down. Do a fourth and a fourth equal a half? Yeah. So if this half equals these 2/4, and this half equals these 2/4, we could say that 2 halves does also equal 4/4. And if it's hard to see it, I'll draw a quick number line here. I'll do the halves on the top, and I'll do the fourths below. So my halves, here's 1/2, here's 2 halves, and my fourths, 1/4, another fourth, I guess I'll do 2/4, 3/4, and 4/4. This is 0 and this is 1. So you can see it on the number line too. Yeah, 2 halves as we showed in our number bond, 2/2 equals 4/4. So boys and girls, the big idea here is that we can write the one whole as fractions, and you can have different unit fractions equaling each other, being worth the same amount too. Okay, last one. What about this one? Is this true? Is this true? Sorry, I'm squeezing my paper. We have 2/2 and we have thirds. Does the whole have the same value as the parts? Well, we have 2/2 and we have 1/3, 2/3, 3/3. 3/3. Now this might look crazy, but if these are both worth 1, we can prove that they are equivalent. 2/2 equals 3/3. 1 equals 1. This is worth a whole, and 3/3 is worth a whole. And you could see it on a number line. I'll do it really quick. 0 and 1. So if we had halves, here's 1/2, here's 2/2, halves. And if we did thirds, okay, I have to get crafty here. Let's see, thirds. 1/3, 2/3. So here's 1/3, here's 2/3, and here's 3/3. So bingo, we can see it on a number line. And today you're also seeing it in a different way with a number bond. But this 2/2 equals 3/3. This is true. So yes, it is. And kids, you are learning a big, important lesson about fractions and whole numbers. There will come a day in math when you take your whole numbers and you turn them into fractions so that you can do new things with your numbers. So this lesson might seem, well, I don't know what you think of this lesson, but I'm telling you it is really important that you know that you can take a whole number and you can view it as many kinds of fractions. That's going to help with your fraction work down the road. Okay, so kids, I want you to go back and finish in your Learn book, page 145, and the pages that follow it. And if you get stuck on one and it's just too hard, it's okay to skip a problem. But otherwise, you could ask me a question too, and I'll help you out. Have a great day.